Warning: tube amplifiers have lethal voltages inside them. Please do not attempt to build, test, or repair these without understanding and following all safety protocols. Hey y'all! Well, today we're going to finish up this series doing a deep dive into the schematic of this EL34 amplifier that we have in production. And if you haven't seen the video I did on how tubes work, it's linked below. It's on a simpler amp that's only got one tube, and actually just one triode is what's working. And it was a really good little project to show you how tubes amplify a signal. But in this video, not going to go that elementary into the whole concept. I'm going to assume that you've seen that video or you understand how that part works. And I'm going to go through the circuit step by step and just kind of show you how things work and why we did things the way we did. And started building these amps in pairs. It seems to be a good way to do it. It's not overwhelming, but it kind of, you know, when I'm wiring up stuff, it makes it easier to just like, I go to this one and then go to this one. And I think if I tried to do too many of them at a time, it would get just overwhelming. So this seems to work well. And you can see this is our base model here with the EL34 transformers and, you know, all the kind of basic parts. We still use, you know, some audio note components and Mundorf coupling caps and that kind of stuff. But this is the higher end version. A customer said, hey, I want to go with the ISO Tango iron. You know, if you see any other things that we can upgrade in it, we're using some pretty expensive non-inductive cathode resistors on the power tubes. We're using these, you know, almost 3 times as expensive gold built-in tube sockets, the black ones with the gold pins. And so, you know, there is an upgrade option available if you're interested in, you know, taking this thing kind of to the next level. This is what I personally listen to, is these ISO Tango transformers on mine. And honestly, guys, I'm not sure if this doesn't sound better at the end of the day than my 300B amp does. It's what I've been listening to lately. Now, it doesn't sound as good as those KT120 monoblocks. I'm not gonna go there, but this is a nice little upgrade, and I have to sit down and figure out. I think it's probably going to be about $500 on top of the normal price to do the little upgrade kind of a deal to it. But anyway, that's not the purpose of this video. We are here to talk about the schematic, go through, show the power supply all the way to the speaker jacks. So let's get busy looking at this little amp. Okay, first let's go through the power supply schematic. We'll go through the primary side first. Over here we have the IC connector, and I'm using a connector that has a integrated fuse holder as part of it. And so you don't have this external fuse. You want the fused side of the IC connector going to the switch. So if something does happen with a switch and it shorts out, it'll blow the fuse. Then it goes to the primary winding. It comes back here to the other side of the IC connector. Here's our safety ground. Now this is the wire that comes off the IC connector and goes to the solder lug that's attached to the chassis after you grind the paint or powder coating or whatever off of it. Make sure you've got a good solid electrical connection, and then use a star washer, double nuts, whatever is required for your code where you live, and make sure that it's on its own dedicated ground. Don't hook anything else up to this except the chassis. This is what keeps the amp safe, where if something else happens in the amp, the metal parts, the outside of the amp are connected to earth ground, so that if there is an issue, it'll blow the fuse and the outside of the chassis cannot get electrically hot. So let's go to the heater wires. Okay, so we have the 6.3 volt heater winding. The center tap goes to the ground. I'm connecting it to the same star ground point that this rail is connected to. So the heaters are connected in parallel, starting with the 2 output tubes, and then you have the input tube at the end of the chain. I'm only showing one tube here, but there'll be 3 tubes on the 6.3 volt rail. Next we have the 5 volt rail. It connects up the pins 2 and pin 8. The high voltage DC comes off pin 8. And then finally we have the primary 700 volt winding. It goes to pins 4 and 6. And the center tap comes over here to the star ground point, which is where this first cap in this capacitor input power supply is connected. Real quick, let's go over the transformer before we finish up with the wiring here in the power supply. We're using a Hammond 273BX, which is rated at both 115 volt and 125 volt. We're using the white and black wires, which is the 125 tap on this primary. If you live somewhere outside the US and you have different voltage, you want to use this 373BX. It's a little more expensive, it's a little bigger. It's got a bunch more wires coming out of it. You can go to Hammond's website and it'll show you how to wire up the various colors on the primary to get the input voltage that you need for where you live. But again, if you live in the US, just get this 273BX and use the white and the black wires on the primary. And again, it's 350 volt, 350 volt, 201 milliamps, which is well within spec. Basically, it's a 700 volt with a center tap. And then we got 5 amps on the 6.3 volt, which we're not using near that much. We also have 5 volts at 3 amps. So if you wanted to use something like a 5U4 or some other kind of higher current rectifier tube, there's a little headroom for that. But the 5AR4 is a 2 amp one. And all of this is overrated a little bit, not excessively. Helps keep the transformer from getting too hot, and even rated like this transformer gets pretty warm, so don't try to spec anything smaller than this. So let's get back to the power supply. Here's our high voltage DC. First thing it sees is this 22 UF 630 volt film cap, that Soldering cap, and it's connected from pin 8 to the star ground point. Then it goes through this 5 Henry, 65 ohm DC resistance, 200 milliamp choke, 193H Hammond that sits on the top of the chassis. From there it goes to this 100 UF 500 volt cap. It's electrolytic. And we're using a little higher voltage here than maybe we would absolutely have to, just to give us a little headroom in case the rectifier is on a warm start and the high voltage comes up faster than the tubes start conducting. We don't have a spike past what the cap's rated. So 100 UF 500 volt is our next step. Then we have this 50 ohm 5 watt resistor, which creates a RC second filtering stage, which helps clean up the B plus supply. So it goes through this 5 watt 50 ohm resistor. Then we have a 220 UF 500 volt cap that connects to the ground to this, and then a wire runs over to our star ground point. If you look at the actual wiring inside the amp, that this is kind of a remote ground point, and then this wire runs over to our star ground point, and then somewhere across these caps, doesn't really matter where, we put this 510K 2 watt bleeder resistor so that in case the amp gets powered up without any output tubes, it's got something to drain these capacitors when you turn the power off. And then this is our B plus that goes to the amplifier itself. So let's move on to the amp. Here's where the power supply comes into the circuit. We have 430 volts DC approximately coming in on this point of the design. And let's do the output tube first. So the power comes up to the output transformer, goes through the output transformer, comes up here to the plate of the output tube, which we have 425 volts sitting right here on the plate. The other voltage that's going to be coming out of the transformer is this ultralinear tap, which powers the screen and also provides a little bit of local negative feedback, which is really what's awesome about ultralinear transformers. Is it's using the transformer itself to help control some of the distortion. Now, some amps, they just hook this right up to the screen, or they use like a 100 ohm resistor. I'm a big fan of using something around a 1.2K resistor so that we drop this screen voltage slightly below the plate. And you're probably going to see about 423 or something right here on the screen. On this side, it's going to be a higher voltage than this because it's not as far down the winding and there's not as much DC resistance between this point and that point. And while tubes seem to live there, it just doesn't make sense to me to run the screen higher than the plate, just looking at the way the tube works. And so to my brain, it makes sense to put like a 1.2K resistor here, which acts as a screen stopper and also drops this voltage down just below the plate voltage. So on an EL34, pins 1 and pin 8 are not internally connected inside the tube like they are on like a KT88 and some other tubes. So you have to connect pins 1 and 8 externally on the tube socket. And this is the suppressor grid. And this is the signal grid or the control grid. This is our cathode. Cathode comes down here. We got a 500 ohm 10 watt resistor. We've got this 220 UF bypass cap, which bypasses this resistor. Any AC that's in this signal gets shunted to ground through this capacitor. And then this is all grounded. Now the only connection here that crosses is this one right here, and you can see it doesn't have a dot on it. That's not electrically connected. Only these ones that have the dot are electrically connected. So this wire crosses over here, just so you're not confused. So anyway, this cathode resistor hooks up to ground. And that completes the output tube current path. So let's go through to the current path for the input tube. Power comes up, goes through this 4.7K dropping resistor, and what this resistor and this cap do is it creates an RC filter that isolates this power here from any noise coming in from this power source because of the current of the output tube. So it electrically isolates the input tube power from the output tube power. Really important. If you don't have this in an amp, it'll motorboat or make just weird funky noises. So this is an absolute necessity. Now some amps combine both channels into just one RC filter. I like having one for each channel. And you're only talking about two fairly cheap parts. So I have a separate RC filter for each channel on the front end. So we have 425 volts sitting right here. Goes through this 240K plate load resistor. Comes up here to the plate. Again, we have our control grid. We have our cathode connected to first a 160 ohm resistor, and then it goes through this red LED. It's a special one that you need to use the one in the bomb. Don't try to use just some cheap little red LED you have. They don't all sound the same. And the ones that I have spec'd in the bomb sound nice and clean. So we get 1.6 volts drop across this LED. We get another 0.2 volts drop across this resistor and end up with 1.8 volts on the cathode. Having this resistor unbypassed gives just a breath of some local negative feedback. I think they call that degenerative feedback. And so that's one of the reasons that we add this resistor with this LED and not just use a straight LED, is this helps clean up a little bit of the distortion in the front end tube by having this resistor separate from this LED and it's unbypassed. So anyway, let's follow the signal through the amp. So here's our input. We have a 100K potentiometer to ground, and this creates the input impedance of the amp is this 100K across this potentiometer. We pull the signal off of this potentiometer, off the wiper, so that we can adjust the signal strength from either ground, zero volume, or max volume connected straight to the input. Comes up here, goes to the grid of the tube through this 1.2K grid stopper, which helps eliminate any oscillations that might try to get developed because it's a fairly high gain tube. Then we have this 1 meg resistor, and this is basically just a safety resistor. Doesn't have to be here. There's a lot of amplifiers that don't have this, and they rely on the grid referencing ground through this potentiometer. Two problems with that is that tends to make this potentiometer noisy because you've got some DC running through it, or all the DC running through it. The other problem is if this wiper ever gets dirty or gets an open spot in it, and for some reason isn't connected to ground, then the grid has no reference to ground, and the tube bread plates and bad things happen. So this is just a safety resistor. Now, if you're going to build this amp with no potentiometer, you want to change this to a 100K resistor and just hook this straight to the input and just eliminate this potentiometer. Don't use a 1 meg if you're going to build it as a power amp with no volume control. You still want to have this 100K input impedance, so you just put it here from the grid to the ground. So the signal comes in here. The voltage varying on the grid varies the current going across this tube. What this plate load resistor is it's creating a situation where when this current across the tube changes, this voltage is going to go up and down in relation to the current, or how much voltage drop you see across this resistor is going to change based on how much current is flowing through the tube. And that's what creates the voltage swing or the amplification of this signal to where it is at this point. So we have this 0.22 UF coupling cap that goes between the plate of the input tube and the grid of the output tube. And then on the output tube, we have this 510K grid leak resistor, which after the grid stopper, it references the grid to ground. What the tube's looking at is the difference between the grid and the cathode on both these tubes. And these are cathode biased tubes. And what that means is this 31 volts that we're seeing right here, that's the bias voltage here. It will actually be a negative 31 volts in relation to the cathode. Same here, the grid will be a negative 1.8 volts reference to the cathode. And then the same thing happens here. When the control grid is swinging up and down, it's changing the current across the tube, which is then reflected through the primary winding of the output transformer to the output. And then the turns ratio drops this impedance from 5K to 8 ohms so it can drive your speaker. The other thing you want to do is you always want to connect the output negative to the star ground point. And that's so that if something really weird happens inside this output transformer and the windings short out, you don't end up with high voltage DC on the output of the amp. It'll blow the fuse. So the last kind of unique thing that I like doing in my amps is called plate-to-plate or shade local feedback. Okay, so what a lot of amplifiers do is they use what's called global negative feedback. And it'll pull portion of the signal off here. It'll come up across, go through a resistor, so it knows with a capacitor across it. Comes down here and connects up to the cathode of the input tube to insert the negative feedback to help lower the distortion, which is something that a pentode and even a ultralinear amp need to reduce the distortion that they have. Really can't run these with zero negative feedback like you can a triode amp. Instead, I use this plate to plate or shade local feedback, and you're basically pulling some of the signal off of here, running it back through and to the plate of this tube, but really it's inserting it back through this coupling cap to the grid of the tube. And so it's just going in like a circle like this. And that's helping reduce the overall distortion. One thing nice about this is changing this value changes kind of the whole feel of the amp. You can adjust the input sensitivity. You can adjust the tonal range of the amp. I found that the higher this value is, the more bright or more top-end heavy the amp sounds. And if the amp sounds too bright, you can lower this resistance and it will tone down the top end of the amp, but it does reduce the input sensitivity a little bit, but it also reduces the distortion too. So it's kind of a balancing act. I usually just adjust that by ear. I start usually around 300K. Some amps I've gone up to 1 meg, which is very little negative feedback. Other amps I've gone down to 200K. And so 200K to 1 meg is kind of the range that you can play within safely. So if with your setup, you know, the system sounds too bright, you can lower this down to 330 or 300K and it'll tone it down. If it sounds kind of dull, you can raise this up to 420K or 470K or, you know, whatever you want to try, 750K, and just play around with this until the amp or your system sounds like you want it to. And that's basically how this amp operates. So, hope this all makes sense. Hope this helps you kind of understand what's going on anyway. And it's like a great place to wrap up this video. Well, hope you found this video educational. Felt it was a good place to wrap up this whole series. And so you're understanding what you're building in case you have problems in the future as well. Or if you have to go back in and do some diagnostic stuff, you understand like what's going on and where you should be seeing XYZ. If you need to, use a signal generator to inject the signal in a scope and look for the signal through it, you kind of understand what's where and how to find the problem if you do end up having one in the future. Do want to make a little plug for this Hakko soldering station. I know all these projects require a lot of soldering, and it's worth getting a nice soldering iron. And I've been using this thing for years. It's just been bulletproof. And I mean, I've done stupid things like leaving it on overnight, and I come in the next morning and I'm like, God, this thing's been on for 8 hours. And no worse for wear. And you're looking for something that's really bulletproof. I haven't even had to replace the tip. So just really high quality stuff. The last thing I'm going to make a pitch for is if you're running tube gear, get one of these manual reset GFI outlet things, little wall warts. Plug this in the wall, plug your tube gear in it. Has no impact on anything as long as everything's working well. There is a ground fault, which is important with tube gear because this stuff is not double insulated. And if the safety ground isn't actually connected to the fuse box all the way to the amplifier chassis, if a fault happens inside the amp, the chassis could get hot and someone could get electrocuted. I can't stress enough the safety of this stuff. And like, especially when you got these little bare metal tube rings and stuff like that, there's a chance that you could get electrocuted. And a lot of volume controls, these audio note ones that I use aren't like this. They've got a plastic shaft and the body is insulated. But like those Alps pots, they're metal with a metal bushing and a metal shaft to a metal knob. And if the chassis gets hot, there's 500 volts sitting there on the volume knob. And so, yeah, get one of these. The second bonus of these is if you have power interruptions and like the power goes off, on. First time it goes off, this thing trips. And when the power comes back on, it does not auto reset. You have to go manually push the button again, which I know sounds like a hassle, but it'll keep the rectifier tubes from blowing up. And they use these on job sites so that, like, if you got a power saw, the power goes off. When the power comes back on, the saw doesn't just start right back up. And so they're designed to work like this, and they're less than 20 bucks, and they're a good way to make sure that you're safe and your equipment's safe. So I think it's a good place to wrap up this video. If you enjoyed this video, please subscribe, please like the channel. Hope y'all build one of these little amps. They're not that hard to build. If you've never fabbed stuff before, go build the little headphone jack adapter box as a first kind of trial thing and to develop your skills. And I've heard people say, I don't want to go out and buy a bunch of chassis punches and stuff if I'm only going to build one chassis. Buy them on eBay used, and then when you're done building your chassis, sell them back on eBay used. That way you don't lose any money. You can sell them for what you paid for them, and then you can build your chassis with them. So that's just a little tip on if you're going to do a one-off thing and you have to buy a couple of what would be new, a couple $100 on chassis punches, go buy some used on eBay for 50 bucks, use them, and then sell them on eBay for what you paid for them. So there's a little tip on that. So anyway, thanks again for all you subscribers, you Patreon supporters, and we'll see you soon on the next video. Have a nice day.